Okay, we're going to talk about 11.2 here. So the warm-up questions for this section are good ones to remember how to find the interior angle measures. So if you have something like a square, we should already know that that's a 90-degree interior angle. Equilateral triangle, 60 degrees. But to find an interior angle of something like a pentagon or octagon, there's two methods to do it. You can do n minus 2 times 180 to find the sum of the interior angles. So let's do that with the pentagon. So for a pentagon, that's 5 minus 2 times 180. So 180 times 3 is what you're multiplying by. Gives you 540. Now that is the sum of the interior angles, not a single one. So you take the 540 and you divide by the 5 angles or 5 sides that a pentagon would have. And if you do that, 5 goes into 5 once. It doesn't go into 4. You have 40 left over. It goes in 8 times. So that interior angle is 108 degrees. Okay. Your other way to find an interior angle, and this is what a lot of you liked once we talked about it, is once we started talking about these, we talked about exterior angles. Well, the exterior angles, one at each vertex of any regular polygon, add up to 360. So if I take 360 and divide by 8 for an octagon, 8 goes into that 4 times with 4 left over and 5, you get a 45-degree exterior angle. So if I know that that's my exterior angle, the exterior and interior angle are supplementary. So if I do 180 minus the 45, I get 135 degrees for the interior angle. So I could have done either one of those methods for either one of those and gotten the same answers that I got there, but those are the two methods you can use to find those angles. And you're going to use those throughout this unit here. Okay, so where do we go with this? We have regular polygons. So it's very important that you understand these are regular polygons. We're not going to find the area of some random pentagon using what I'm going to do here. It has to be a regular pentagon. So there's two big terms here. One of them is an apothem. This is a new term here, but essentially what that is from the center perpendicular to a side, you end up with an apothem. It is the height. Let's see if I can draw a good pentagon here. It is the height of the pentagon. That's not a great one, but from the center, it's the height of the triangle that is formed inside the pentagon there. And if I do it throughout, you'll see that you can make a bunch of congruent triangles. Actually, that picture's down here. You can see the bunch of congruent triangles here, and the height of one of those triangles is the apothem. But it always goes from the center perpendicular to a side. It does bisect that side, and it is perpendicular to it. Okay, the radius, it's important to see it drawn here. So if you see this pentagon with the circle around it, that's the radius. But even over here, this is a radius. Okay, so you're going to see a radius talked about even without a circle drawn in some of these. It's the radius that would be of a circle that is circumscribed about that polygon. Okay, so that's what the radius and the apothem and those terms that we're going to use here. So the formula, and this is one that some of you will use this formula, some of you will use it a little bit differently. But the formula for area of a regular polygon, so it could be a pentagon, it could be an octagon, any of those regular polygons, is 1/2 times a times n times s, or 1/2 times a times p. So how do these come about? They actually start with this one here, and I would take either one on the formula quiz. Okay, so if I look at this and I think about this as a bunch of triangles here, this triangle right here is 1/2 times base times height. Well, the base of that triangle is the s that's here, the side length. And the height of that triangle then is the a, the apothem. Okay, so that's 1/2 times s times a. And then in this case, since there's 8 of those triangles, you would multiply by 8, and 8 represents the number of sides. So 1/2 times a times n times s, 1/2 times s times a times n, whatever order you want it in, that's that formula. How do they get it to 1/2 times a times p? Is the fact that the number of sides times the side length. So think about this here. If you know the side length of S and you have 8 sides, 8 times S is the perimeter. So I can do 1/2 times A times perimeter also and have the same formula. So I don't care which one you use for your formula quiz. Totally up to you as to which one you want to use there, but you can use either one. You do need to use your A for apothem, your P for perimeter if that's what you're talking about, or any of those values. Okay, so there's your formula, and let's go ahead and use it. So there's an example at the bottom of that next page there. I'm going to find it in my book. Bottom of page 640. It has a pentagon here. We're going to assume this to be regular. So if you think about a lot of things that are done in real life, a lot of them are going to be regular figures. Like you're not going to make this coaster and not make all the sides congruent. That's just not the way that's going to work. So we're going to assume this to be a regular polygon. And each side measures 4 inches. So I know that this side length is 4 inches there. So what I need to do is make a right triangle in here. So I'm going to go from the center, perpendicular to the side. That, remember, is the apothem. And then I'm going to connect that to the corner, to the vertex of it. And that, remember, is the radius. So if I redraw that triangle so that we can kind of see it, that apothem, that radius, what I know here on this side is 2 units long, because that apothem does split the full side in half. And so 4 divided by 2 is 2. Okay, so I have that. For the radius, if you are given the radius, you can use the radius to solve for the apothem and for the side length. If you are not given the radius and you're not asked for the radius, there is no reason to solve for the radius. Okay, so you don't need to solve for this in this case. I'm just trying to find the area. I need the apothem and the side length in order to find the area. So all I'm solving for here is the apothem, not the radius. It actually is not needed. Okay, to solve for the apothem, it's not going to be Pythagorean theorem. It's not going to be, in this case, a special right triangle. It's going to be trig. So I need to find this angle right here, which is this angle right here. So if we think through our pentagon real quick here, and we think about it as a bunch of triangles, so there's going to be 5 equal triangles that are drawn in here. I can take 360 divided by 5 to find what each one of those angles in there are. And that's going to give me 72. So I know that this angle here is 72 degrees. But the angle that I have drawn here is actually that angle split in half. There's 2 of them there. So I'm going to take that divided by 2 and get 36. And what that tells me is that this angle that I need there is 36 degrees. Okay, so however you want to do it, yes, it is always 360 divided by the number of sides divided by 2. But if you want to actually just think through it, you can. But we need to get that to be 36. Because it's a 36-degree angle, you are going to be using trig here. Okay, so we have to think through our trig. If with the 36, I have the 2 is the opposite side, the A is the adjacent side. Just to be clear, that A and the adjacent do not stand for each other, so it's not always the case. But that A is the adjacent side there. So I'm going to solve tangent. So I'm going to solve a tangent of the angle. The angle here is 36, is equal to TOA, so opposite over adjacent would be 2 over A. Okay, to solve that problem, when your A is on the bottom, you multiply by A to get it into the numerator. And then since it's A times tangent of 36, and I want A by itself, I divide by the tangent of 36 on both sides. And so what I'm typing in my calculator is 2 divided by the tangent of 36. And that, make sure your calculator is in degree mode when you do this. And you type it in, 2 divided by the tangent of 36 is going to give me 2.75-ish. So my apothem is about 2.75. Now, intermediate rounding errors, do not make that error here. Keep that number in your calculator. Use that whole thing. Okay, so that is my apothem. Formula, 1/2. And I like to rewrite my formulas a lot to practice them. 1/2 times apothem times perimeter. So 1/2 times that 2.75 number. I'm going to leave those little decimals because I'm going to use the whole thing in my calculator. Times the perimeter. So if I go back to this, if one side length is 4 and there are 5 of them, 4 times 5 is 20. So my perimeter is 20 here. So 1/2 times 2.75 times 20. 1/2 of 20 is 10. So I'm really just doing this times 10. And you're going to get 27.5276. Now I can round to the nearest tenth. So I should answer 27.5. Okay, inches squared. So that's the area of that regular polygon that's there. If we switch over to the next page, there's a composite figure. So composite figures at the top of the page, they talk about them, but really it's just that we're going to have a big figure and we're going to break it down into smaller figures. This one here is broken down for us. So we already see the 3 different figures that are happening there, and we're going to find them all separately and just add them together later on. So I'm going to start with the triangle. The triangle here, 1/2 times base times height is my formula. So I have the 5. I don't actually want to use that as my base or my height. Okay, in a right triangle, the 2 legs are the base and the height. So I have this 3 yards that are over here. So all of the sides of the pentagon are 3, and that's going to be one of the sides, and it's a 3, 4, 5 triangle. Hopefully you catch that. So it's going to be 1/2 times 3 times 4 as my formula. 1/2 of 4 is 2 times 3 is 6. So I get 6 units out of the triangle. I'm going to skip over to the rectangle here because that's the easy one. So rectangle is base times height, which is going to be in this case 3 times 8. Which is 24. And then I need to find the area of the pentagon. So it happens to be a pentagon again, which the nice thing about that is that we already know that central angle from the previous problem. So if I draw in my right triangle right there, I know that that angle is 36 degrees. Let me draw that triangle in bigger so we can see it there. So I have a 36-degree angle. The side length over here is the one that I can find. Since the whole length is 3, that is just half of it, so it's 1.5. And I need to find the apothem. Again, I don't care what the radius is right here, so I need to find the apothem. You're going to set up the same trig. So tangent of 36 is equal to 1.5 over a. Multiply both sides by a, and then divide by the tangent of 36. So again, all the same steps that we just did in our last one, which is why I'm kind of going through them quickly. So I'm going to type in 1.5 divided by the tangent of 36. And that's going to give me that a is about 2.06457. And again, it keeps going, so I'm going to keep that number in my calculator. Formula for this one, 1/2 times apothem times perimeter. So 1/2 times the apothem I just found, 2.06-ish, times the perimeter. So with 3 distance on the side, there's 5 sides, is 15. So I'm going to do 0.5 times the apothem times the 15 of the perimeter. And that's going to give me about 15.484. And again, there's a whole decimal in my calculator that I'm keeping there. And all you're doing in this case, if for area of a composite figure, is adding. Just add those together. So take the number in your calculator plus 6 plus 24, and you would get a total of 45.484. Rounded to the nearest tenth, that should be 45.5 yards squared. Okay, so that's your area of your composite figure there. Now we happen to do 2 pentagons, but we don't always get a pentagon, so just remember that. We can use that same formula for other figures here. In this last one here, this composite figure, what you're going to see in some of these composite figures is a drawing like this, and some people get confused. You're finding the area of the shaded region here. The composite figure here is all of the shading. Okay, so this is an interesting one. It is a parallelogram, so I like to look at this and say, okay, what do I have here? It's a parallelogram. Parallelogram. I can spell here, kind of. Okay. Minus, and then inside here, this is either a rhombus or a kite. But really what I care about is that the diagonals are perpendicular. And for any figure where the diagonals are perpendicular, that formula is 1/2 times diagonal 1 times diagonal 2. So that's rhombus and kite. That's why the formula was that case, is because the diagonals are perpendicular. So I'm going to find the area of the parallelogram here. The base of this parallelogram is 14. You can see it there. And the height is drawn off to the side. There is the 9. So 14 times 9 is going to give me 126. You can see that that's one of the answers because a lot of people will get stuck there. Okay. 1/2 times diagonal 1 times diagonal 2. So diagonal 1, this diagonal right here, the reason they show you it parallel is because it's going to be the same as the 14 that's there. Okay. So that distance, this distance, and this one are all going to be the same because of that parallelogram. Okay, and then diagonal 2, the one that's going up and down, is the same as the height of that, is 9. So this formula here, 1/2 of 14, which is 7, times 9 is 63. And we're going to subtract the 2. 126 minus 63 is actually also 63. And so my answer there is letter B. Okay, but think about like what is the big figure minus what is the small figure, and your formulas to go through those to find them. Okay, that's what we have there, and you have your homework to do.